Okay, in this video, at 8.3, I'm going to show you how to use your t-table to calculate your value you need to find the confidence interval. First of all, when do you use the t-table? You use the t-table when we don't know the population standard deviation. For example, we don't have sigma here. This is the standard deviation for the sample. So sigma is unknown, or the population standard deviation is unknown. So we're going to use the t-table. I've answered the first one, and I'm going to I set it up on a spreadsheet, but remember, you can do the same thing on a sheet of paper. I'm just putting it in Excel just so you can see it, but you do not need Excel to be able to do this. So first of all, before I do that, I want to show you in your textbook, and you can access your textbook in MyLabs. What I wanted to show you is some assumptions about the t-distribution. It is bell-shaped and symmetrical. Okay. The shape depends on the degrees of freedom, and to get the degrees of freedom, you will do n minus 1. The area under the curve is equal to 1, just like any normal distribution is equal to 1. But the t-distribution is flatter and wider than the normal distribution, so it's going to be more spread out. The critical score, which we will look up on the table, is higher than the z-score for the same confidence level. And the reason it's going to be higher is because it's less precise, okay? And as the number of degrees of freedom goes up, the shape becomes similar to the normal distribution. Think about it. The more you have in the sample, the more accurate it's going to depict the population. If you only pick 2 samples, does that really represent the population? No. That is not a big enough sample to get an accurate representation of the population. So I just wanted you to see that. You can go back and kind of read over that. That may help you with a few questions. But I'm going to go to my Excel spreadsheet. And this right here is similar to what we did on one of the other videos, but it's how to calculate a confidence interval using the t-table. First of all, they told us the mean was 135, the mean of the sample. Let me just go back and show you. See, the mean of the sample is 135. Then you had 25 for the standard deviation, 95% confidence level, and n in this first one is 20. So I put all that up here. Let me fix this one. I didn't change it. N is 20, and the sample standard deviation is 25. Let's just make sure all this is right. Yes. Okay. So we have all this information up here. Now, step 1, you don't necessarily have to go in this exact order, but you do need to find alpha. And alpha is just 1 minus your confidence level, which is 0.95. So alpha is 0.05. Then compute alpha divided by 2. 0.05 divided by 2 is 0.025. Then you will define the degrees of freedom. Well, we said n was 25, 20. Oops. Let me make sure I got all this right on my notes. I think I've got everything right on the notes. I just forgot to fix it on here. N is not 25, N is 20, so the degrees of freedom would be 19, and then down here I need to fix this. When I worked it on my paper, I had it all right, but I obviously didn't type it in right here. So you're going to go to your table, and you're looking for 0.025 alpha divided by 2, and the degrees of freedom is 19. So these tables are in your appendix, but they provide them. When they want you to use the table, they'll put the table up there. So let's look. We know we want a 95% confidence level. Okay. So if we look at 95%, I'm looking at one more thing before we look at 95%. We need to go, it's the third column from the right side. We need to go to 19. So 0.2093 is our T value, our critical value. So that's how I got 2.093. Now I had to know what my confidence interval was and my degrees of freedom. Then compute the standard error of the sample mean. Since we don't know the standard deviation of the population, we are going to use the sample standard deviation here. And we know the sample standard deviation is 25. So you do 25 divided by the square root of 20. And I did that, 25 divided by the square root of 20. And I got 5.5, a long number. And the reason I know to round it to 4 decimal places is because I looked at the example in the homework problem to see what they rounded to in their example on this part. So we have 5.5902. Now, calculating the upper and lower confidence levels, you do the mean plus for the upper and the mean minus for the lower. And you times the critical value of T. I forgot to change the critical value here that we used. So what I do is I get 135 plus 2.093 times 5.5902. Now you can put this in parentheses, but it's going to multiply before it adds because that's what our order of operations says to do. So there you go. Okay. Now, I needed this number here. Let's do this in orange. Wrong one. Let's do this in orange. And so I needed that number. I'm trying to do it in a color that will stand out. We need this number, which we rounded. So you have to have the standard error number, and you have to have the critical value number. There I go again, doing the wrong thing. I like to use color to help you see. So I plugged in 5.5902 down here. I just completely did not change that. So 2.093 is my critical. I take my critical value, my T value, times this standard error, and that is how I get my answer of 146.70. You round it to 2 decimal places, but mine's only going to show 0.7, but it's 0.70. And then down here, you do the same thing. Your two numbers. This is your T value. This is your standard error value. Multiply those together, the mean minus those two numbers, and this is what you get. And we're going to round that. That rounds up, that 9 rounds up to 10, so it's going to be 123.30. So if we go back to the homework, that is my answer. So that is how you look up the T value. For the Z value, if it's not on that handout I gave you, if it's a different confidence interval than that, use technology. Use StatCrunch. I had a video to show you how to use StatCrunch, but for T-table, look it up. For Z value, look on the chart. If it's not there, you can just use StatCrunch to come up with it. And that is all. That is pretty much how you use the T-table and how you get to your confidence intervals. It's a lot like the Z-score. Just the degrees of freedom is kind of the new part. I hope this video helped you understand 8.3 just a little bit better.